Okay, this will be the third in-class assessment on linear equations. So there's no power here, so it's a line. Now, when you're graphing a line, is it in slope-intercept or is it in standard form? Well, the y is by itself with the x over here, so it is in slope-intercept form. So we need to find the slope and the y-intercept. Well, that's not hard. You just it's mx, so m is 7, and then b. Okay, so my slope is 7, but that's an integer, so we need to make it a fraction by putting a 1 under it. And the y-intercept is -2. So we go y-intercept first. So on the y-axis, you go down 1, 2. Okay, my slope is positive, so I go up 7, and then 1 to the right. So 1, 2, 3, 4, 5, 6, 7, right 1. I can't do it again because I don't have enough room, so I can just go with these points. And the equals is there, so that's how I know it's a solid line, and I don't need to do a test because there's no greater than less than. Okay, 3x plus 2y is less than or equal to -12. Now here's the sign. Now it's a line. What form is it in, standard or is it in slope-intercept? It's in standard because the x and the y are on the same side of our sign here, of our less than or equal to sign. So this is in standard form. And the equals is there, so it's again going to be a solid line. And since I have less than after I get the line, I'm going to need to do my true-false test. So standard form, I want to make a table with the zeros in place of each variable to find the x, the y-intercept, and the x-intercept. So I'm going to write that down twice, but I'm just going to put a regular equals. So 3x plus 2y equals -12. And 3x plus 2y equals -12. So I know if I have the x equal to 0, we can eliminate the 3x term. And then I divide by 2. And -12 divided by 2 is -6. So if I have 0 for x, the y comes out as -6. Y is 0, so I can eliminate the 2y. So I divide by 3. That's -4. So 0, -6. So I stay in the middle. Go down 1, 2, 3, 4, 5, 6. And then x is -4, y is 0. So I go left 1, 2, 3, 4, and then I don't move up at all. And it's a solid line because we have the equals. But I'm not done because now I have to actually account for the less than sign. So what is the best point we could plug in for x and y to do a test? Right there, 0, 0. So x is 0, y is 0. Okay, so copy that down, the same thing. So 3x plus 2y less than or equal to -12, and we need to replace both the x and the y with 0. So what's anything times 0? 0. What's anything times 0? 0. So 0 plus 0, 0. You should be able to do that in your head. So 0, the sign, and -12. Now 0 is the larger value, and the sign is not opening up towards the 0, so that makes that a false statement. So this point is false, and the other side of our line is true. Okay, solve the inequality. Graph your solution with a number line graph. So let's make the number line graph. And we need to isolate the x, so I circle that. And is there a negative in that? there is. So that sign right away we know is going to switch down here. If there's not a negative, then we keep the sign the same. So I'm minus 13, minus 13. So I have negative 5x greater than or equal to 10. And now it's time to divide. And when I divide, I want to transfer my work over here. So I have x. 10 divided by negative 5 is negative 2. So negative 2 is the critical value. The bar is there, so circle it. And less sign goes this way. Okay, solve the equation. The absolute value of 3x plus 2 equals 17. Remember, absolute value means distance on a number line from 0. So there are always two distinct places where you can be a certain distance from 0. So we need to make that table. Now, is the outside of the absolute value clear? Yeah, it is. There's nothing in front. There's no plus or minus behind the absolute value. So we can go ahead and now go to my table. Where are the two places you can be have an absolute value of 17? Where you can be 17 places from 0. 17, negative 17. And then I set the expression inside equal to each value. Then I solve it. So I'm minus 2, minus 2. 3x equals 15. Divide by 3. And I get 5. Minus 2, minus 2. 3x equals negative 19. Divide by 3. Negative 19 divided by 3 is negative 6.3 repeating. You can put that, or you can just leave it improper. Okay, rewrite the equation so the y variable is by itself. Okay, so we're getting the y by itself, so I need to can't undo the 4x. So it's positive, so I'd subtract it. But 4x cannot be subtracted from 20, so we want to put that behind. Now we need to undo the multiplication of 5. The opposite of multiplication is to divide, so I divide by 5, and then we need to divide each term by 5. So I have y, 20 divided by 5 is 4, and then I take negative 4 divided by 5, negative 0.8. And that needs an x factor on it because the x does not go away, it stays there. Now you are also more than welcome to leave that as negative 4/5. Okay, perfectly okay with that. That's actually probably better, but I don't want to be throwing a bunch of things in your head. Okay, story problems. The standard has a lot of story problems. Okay, 2 units, you want to make your boxes, and these will be linear. 3 units the chart, and then if you're talking a distance, speed, time problem, we want to go with this. So I can type 5 pages in 2 hours. My friend can type 7 pages in 2 hours. How long will it take to type set 25-page paper if we work together? So we're finding the number of hours, so there are 2 units. So we want to try to analyze a problem using the 3 boxes. My units in the problem are pages and hours. The hours is the time unit. That needs to be assigned X. The pages assigned Y. So per pages per hour. Okay, I don't know the pages per hour. 5 and 2, 7 and 2, and they're different rates, so let's leave that empty for now. Now think, you're doing work. If you type for 0 hours, would you get any pages typed? No. So this is a direct variation. So if it is a direct variation, we need to make some ratio lines. But we're going to need 3 ratio lines here because I've got me, my friend, and the together. Okay, you want to put your X unit on bottom and your Y unit on top. Okay, so 5 pages in 2 hours. My friend can do 7 pages in 2 hours. And when we work together, we need to type a 25-page paper, and my answer is the number of hours it takes to do it. Okay, so I know I have 25 over X, but I'm going to need to add these 2 ratios, okay? Answers, I'm going to tell you right away how you know it's 6, but I'll prove it on the calculator. These have common denominators already, so it'd be 5 plus 7, which is 12, and 12 over 2, which is 6, you know. So 6, and you can make an integer into a ratio simply by putting a 1 under it. And then you cross multiply and divide. The product of 1 and 25 is 25. So it's 25 divided by 6, which is 4.16. So a little over 4 hours. Okay, 2 people are going to combine their earnings to buy a vehicle. The husband worked 160 hours last month, while the wife worked 170 hours last month. The wife earns $2.50 more per hour than the husband. Their combined earnings were $5,375. How much does each person make at their job per hour? There are 3 units. You have the hours worked by the husband, the hours worked by the wife, and then the money. So we need to make our tic-tac-toe table. So total, or no, not total, together. Then I got husband, wife, and money, so we'd put the husband, the wife up here. Then how many units? Single, and total. And then the third unit, the dollar sign, is placed here, but not here. This row has nothing to do with money. Okay, I give myself a money total. Well, 5,375 appears to be my money total. Remember, this row here has nothing to do with money. So 160 goes in that row, and that's for the husband. As soon as it plays, cross it off. 170, that's for the wife. And since I knew these 2, I really have no need to use this. Sometimes I do, but not here. Never need that one. Now you're looking for money amounts, and you see the wife earns $250 more per hour. So you don't just put 250. More than means we use X plus 250 for one of these and X for the other. Now the wife earns 250 more, so X plus 2.50 and X. So I find that product. Now you have a plus sign, so you need to put a 1 in front and use your distributed property rainbows to find that product. So that's going to be 170X. And then I need to take 170 times 2.50, and that gives me 425. Put equals. Now you have 2 variables, and they're the same, so you can just go ahead and add. 160 plus 170 is going to be 330. X plus 425 equals 5375. Okay, isolate the X, and you'll have your first answer. So 330X. 4,950. Divide by 330. And I get 15. Now go find the solo X in the table right there. That would be your husband's wage per hour. Now the wife's wage, very easy. We didn't know it, but we know it's $2.50 more. So I just plus 2.50, and that would be $17.50. Okay. An internet service charges $50 for installation plus $40 per month. If a person has paid the company $490, for how many months have they had service? Okay, so months. Now you're back to 2 units. So the relationship is discovered through these boxes. This is an easy problem. A lot of you could probably do it just without all this crap. So money and months. X is months, Y is money. So per dollars per month. Dollars per month is 40. So it's a line. The reason these are all lines is because the money's only going to keep going up. Okay, it's not going to come back down. So X comma Y plus MXY. And we need to put that 40 for our M because we have that. And prior to $40 per month, we had to pay a $50 service charge. Okay, so 50 plus 40x equals y, and our replacement value is $490, which goes in for the y. Okay, so that means you need to sign the x yourself. It's not by itself, so isolate it. Minus 50, minus 50. So 40x equals 440. Divide by 40. Divide by 40. 11. Okay. So 11 months. Okay, Tom has $600 while Bob has $100. Tom spends his money at a rate of $20 per month, while Bob saves his money at a rate of $30 per month. After how many months will they have equal amounts of money? So this has 2 units in this problem of importance. Now you're like, why not? Why is it 2 on this one and not 3? Because you got Tom and Bob. Because the months are not different, okay? It's like a race. It's a competition who can get more in the amount of time. It's like they're timing it and time runs out. And that husband-wife problem, they were working for different hours. So that's why you needed to differentiate there. So I've got money in months. X is the months, Y is the money, so per dollars per month. Okay, I've got $20 per month for Tom, and Bob is actually negative 20 for Tom because he's spending it, and Bob is positive 30. So we need 2 lines to represent each individual here. So X comma Y plus MXY. X comma Y plus MXY. Okay, negative 20 is the first rate of change, and 30 is the second. Prior to the $20, this guy, or that's Tom with the $20 per month. He had $600 prior. And with Bob, the prior amount was $100. Okay, so you want to know when are they equal. So I have 600, either minus 20x or plus negative 20x. And you want to know when that equals 100 plus 30x. Okay, we need to collect these x's here. They're on opposite sides, so we need to balance the smaller one out of the equation, plus 20x. Then I won't have to worry about any more negatives. So I have 600 equals 100. You're finding what x equals. 600 equals 100 plus 50x. Now I isolate the x. Minus 100 minus 100. So 500 equals 50x, and then I divide by 50, and that's 10. Okay, so it takes 10 months. Okay, next one. I am losing weight at a constant rate each week. 3 weeks after I cut weight, I weigh 205 pounds. 6 weeks after I start cutting weight, I weigh 190 pounds. I want to stop when I'm down to 170 pounds. How many total weeks of weight cutting is this? So weeks. And again, you got 2 units, and I wrote a little note here for when you draw the line. Okay, pounds and weeks are the 2 units. Weeks is a time unit, so that would be our x, and pounds. So per, pounds per week. And I don't know the pounds per week, okay? Don't know that just by reading it. So x comma y plus mxy. Now, I wrote you a little note. The y does not begin at 0, but you don't know where it began at. It's not 205. That's after 3 weeks. That's not the beginning of time. 190 is after 6 weeks. So, since it doesn't begin at 0, you're going to have to use your y minus y, x minus x, your slope-intercept formulas. Y equals mx plus b, m dot x. Okay, so the y is our pounds. You got to put the right, so I get 205 and 170. And the x stands for the weeks, so that would be 3 minus 6. All right, so 205 minus 170 is 35. Or no, it's not 170. It would be 190. Sorry. 170. Not 170. It's 190. Dang it. 170 is the replacement value. Okay, so that's going to be 15 over negative 3, and that's negative 5. So you're losing 5 pounds a week. Because 170 pounds didn't have a number of weeks to go down with. That's going to be the replacement value. I'll just put that down here. Okay, I need the combo. They got to be in the same sentence. 3 and 205 will work. 3 weeks. 205 pounds. And remember, we're solving for the b, so every other variable needs to be replaced with a value. So the y is pounds, and I have 205. The m would be the negative 5. Then x is weeks, so that would be 3. So I have 205 equals, find that product there, that's negative 15. Plus b, put a 1 in front, and we isolate the b by adding 15. Okay, so 205 plus 15 is 220. So 220 equals 1b. We don't divide by 1, so the beginning value is 220. Okay, so my equation is 220 plus negative 5x equals 170 equals y. Sorry, I'm getting ahead of myself. Y. And 170 pounds goes in for y. Now we can put 170 in there. So 220 plus negative 5x equals 170. You need to get the x, but you're solving for by itself. Undo the 220. So negative 5x. 170 minus 220 is negative 50. And then divide. And that is 10. Okay, so 10 weeks. Okay, plane A and plane B travel for equal amounts of time. Circle that. The first plane travels at a constant speed of 700 miles per hour. The second plane travels at a constant speed of 775 miles per hour. The faster plane travels 800 miles further. How far did each plane travel? I don't need units. I need a distance, speed, time table. So these are planes. So object 1, object 2 would be plane 1 and plane 2. We have speed. Remember, speed is distance divided by time. We have the distance. Remember, speed's miles per hour. Distance is just miles, and that would be S multiplied by T. And we have our time, and that would be our distance divided by our speed. Okay, so what are the speeds? Miles per hour is the speed. You have 100 miles per hour, and you have 775 miles per hour. Cross those off. Distance is about the miles themselves. Well, I see I have 800 miles, but it says further. So then I have to put X plus 800 and X for these two. Okay, so the faster plane is going to be the X plus 800, and this is X. Now, it appears we are out of values, so I need to use the distance over speed. So the distance for this car is represented by X, and the speed is 700. The distance, or the plane, I should say. The distance for this plane is X plus 800, 775. Okay, and you want to know, you know that they travel for equal amounts of time. So you know that these expressions are equal. So you know that X over 700 equals X plus 800 over 775. Okay, now you got to find the X value. There's two of them, so you will not be able to, you need to use your A, B, C, D cross products. So set up an equation with parentheses. So A multiplied by B, C multiplied by D. So A is X, B is 775. C is X plus 800, D is 700. Put ones in front. Okay, so that's 775X. And then distributive rainbows, you need 1 on that side, 2 over here. So it's going to be 700X. So 700 times 800 is 560,000. So subtract 700x, subtract 700x, so I get 75x equals 560,000. Divide by 75, divide by 75. Okay, I'm going to ignore all that crap after the decimal. 7,467. Okay, the miles. Well, now that we know the solo X, you can just add 800. So plus 800. $8,267. Now these are planes, mind you, so they're probably traveling overseas. Okay, and then our last problem. The soccer coach is buying soccer balls and bags. The soccer balls cost $11 each, while the bags cost $17 each. The coach buys 32 items for $424. That should be $424. How many of each item did he buy? So you're back to 3 units. So together, and balls, bags, and money. So I'd want to put the balls and the bags up here. How many? Single and total. And then the third unit's the dollar sign. So you want to put that here and here, but not up here. That has nothing to do with money. Okay, so total is $424. Cross that out. Now look for numbers that have nothing, values that have nothing to do with money. Again, 11 doesn't belong here. 17 doesn't belong here. Okay, 32. It says 32 items though, so that goes here, and then we need to use X and Y. Okay, I don't have a use here. Okay, I see $11. That's some soccer balls. And $17, that's for the bags. So 11X, 17Y. Okay, so equals, but unfortunately you got two different variables, so you're going to need another equation, and that comes from up here. So set up your cross for the system. So we have X plus Y equals 32, and we also know that 11 times X plus 17 times Y equals 424. Okay, you don't have a match, so you need to do your multiplication. Okay, the 11 comes up here, and I multiply all these terms by 11, and then 1, 1, 1, 1. So it's going to be 11x plus 11y. And then 32 times 11 is 352. Then you're going to have 11x plus 17y equals 424. And now you have your match right here. But and you want to add, but 11 plus 11 is 22. So you can fix that by changing the signs. And what you're really doing when you change those signs, you're multiplying that all by -1. So cancel, I get -6y. 352 plus -424 is -72. So divide by -6 and you get 12. Okay, that's Y. So the bags cost, you have 12 bags. Now you can use common sense. If you know they equal 32 and you know Y is 12, I think you can find that pretty easily. But if you want to plug it into the original and do it by the book, that's fine. Answer for Y is 12. So 1x plus 12 equals 32. Minus 12 minus 12, that's 20. All right, that's it.